Okay, question 5 for 5 marks. Given that y is equal to 3 sine theta over 2 sine theta add 2 cos theta for theta between minus pi over 4 and 3 pi over 4, we want to show that dy by d theta is a over 1 add sine of 2 theta, where a is a constant to be found. So this is going to be differentiation using the quotient rule with trigonometry. So we are given the quotient rule in the formula booklet. Here it is. Now we usually use u and v. Here they're using f and g. So we're going to say then that f of theta is 3 sine of theta and then f dashed is going to be, well, sine differentiates to cos. So it will be 3 cos theta. We're then going to say that g is equal to 2 sine add 2 cos. Okay, and then g dashed is going to be 2 cos of theta. Now, cos of theta differentiates to minus sine theta. So we're going to get minus 2 sine theta. So, putting that together, we can get then that dy by d theta is equal to, now it's f dashed times g. So that's going to give us 3 cos of theta times g, so times 2 sine theta and 2 cos theta minus, so now it's f times g dashed, so minus f times g dashed. So we got the minus, so we got 3 sine of theta times g dashed, so times 2 cos of theta minus 2 sine theta. So that's what we got up on top. Now on the bottom we get just g squared. So 2 sine add 2 cos all squared. Okay, so let's expand and simplify. So up on top we have 3 cos of theta times 2 sine of theta, so that's going to give us 6 sine theta cos theta, and then we got 3 cos times 2 cos, so that's going to give us 6 cos squared okay, and then we got minus 3 sine times 2 cos, so minus 6 sine theta cos theta, and then we're going to get minus 3 cos times minus 3 sine times minus 2 sine, which is going to give us plus 6 sine squared. Of theta. Now that is all over. So 2 sine add 2 cos all squared is going to give us 4 sine squared and then we're going to get 2 lots of 2 sine theta times 2 cos theta, so that's going to give us 8 sine theta cos theta, and then we're going to get 4 cos squared theta. Okay, so luckily quite a lot cancels out and combines it. So up on top we got 6 sine theta cos theta, and then over here we got minus 6 sine theta cos theta. So that cancels out with that. Now up on top then we're going to be left with 6 cos squared and then we got add 6 sine squared so that's what we got up on top. That's going to factorise and do something nice for us in a moment. Now on the bottom, let's rewrite it a bit. So we got 4 sine squared theta add 4 cos squared theta and then we got add 8 sine theta cos theta. Okay, so now we need to get some identities working for us. So first up, sine squared add cos squared is equal to 1. That's going to help us a lot. And also, sine of 2 theta is equal to 2 sine theta cos theta. So, up on top, we can factorise. Say that we got 6 sine squared add cos squared. On the bottom, we can also do that. We got 4 sine squared add cos squared. And then 8 sine theta cos theta using the identity is 4 times sine of 2 theta. So we got add 4 lots sine 2 theta. So the top just becomes 6, because sine squared add cos squared is 1, so we got 6 over 4 add 4 sine of 2 theta. Okay, now then, let's have a look at how we wanted it. So we wanted to get a over 1 add sine of 2 theta, where a is a rational constant to be found. So it didn't say integer. So what we can do now is divide everything through by 4. So we're going to get 6 divided by 4 is 1.5. So we get 1.5 over 1 add sine of 2 theta. Job done.